Hi everyone, I hope you're having a good day right now. We're on section 3.4, day 2. We're doing what's called linear programming. So this is it's a difficult lesson because it takes a lot of comprehension. So make sure that you have complete focus now as you're watching this video. Put away all other distractions. I need you to have 100% focus on this lesson to make sure you understand it. So we're having some word problems, and here's the process here. We're going to read through this word problem, understand it. First step is we're going to define some variables. Pretty simple. After that, we're going to write a system of inequalities. This, I dare say, is probably the hardest part of this lesson, is to write a system of inequalities. Once we have our inequalities, we're then going to graph it. After we graph it, we're going to write a function to be maximize or minimize, and then we're going to fill out this chart, very similar to what we've done in a previous video lesson. So let's talk about each one of those steps. First, we're going to read through the problem and understand it. So as a vet, Bryn has her receptionist schedule appointments. She allots 40 minutes for a surgery and 20 minutes for a routine office visit. So if she has 3 surgeries, now there's 120 minutes. If she has 4 surgeries, 4 times 40 is 160 minutes, so on and so forth. If you have just a routine office visit, she could see 3 routine office visits in an hour because that's 60 minutes. So hopefully that all makes sense to you. I hope that that sentence makes sense. Bryn cannot do more than 6 surgeries in a day. There must be some sort of restriction. Maybe it's stressful on her. Maybe she needs more help with surgeries and the time allotted for her helpers doesn't allow. Whatever the case might be, she can only do 6 surgeries or less. She cannot do 7. She could do 2, 3, 4, 5, or 6, but she cannot do more than 6. The office has 7 hours available for appointments. So a typical workday is 8 hours. Maybe she's in a meeting for 1 hour that day. Whatever the case might be, she only has 7 hours, which is 420 minutes, for these appointments and for these surgeries. So that's how much time she has. An office visit costs $55. So if she does 1 office visit, she just gets $55. If she does 2 office visits, well, 2 times 55 is 110. So then she gets $110, so on and so forth. A surgery costs more money. It's $125. So if she does 1 surgery that day, there's $125 in her pocket. If she does 2 surgeries, now it's $250, so on and so forth. So now it says, find a combination of office visits and surgeries that maximizes the incomes Brett's vet practice receives per day. Bryn wants to make as much money as possible. So is she better off doing more surgeries, more office visits, or a combination of the two? So that's what we're going to try to figure out. We want to know, how can Bryn make the most amount of money with this information that we're given? So the first thing we're going to do is we're going to define the variables. This one is actually quite simple right away because in your notes, you see what the x-axis is. If you look on your graph right here, it says surgeries. So we're telling you right now that the x-axis is surgeries, and here is office visits. Office visits. The y-axis is office visits. So defining our variables, x is surgeries. The y-axis is office visits. So hopefully that's pretty straightforward right away. The next part is the most difficult part. It's write a system of inequalities. I'm going to tell you where you should always start. The very first thing we should do is we should look at this problem and say x has to be greater than or equal to 0. The number of surgeries she can do in a day has to be bigger than 0. There's no such thing as doing a negative number of surgeries. That's just impossible. In the same way, y has to be greater than or equal to 0. There's just no possible way of doing a negative number of office visits. So it's got to be 0 or more than that. Okay? So those are 2 systems of inequalities right off the bat that are going to be true for almost all of these linear programming problems. So now let's go back and read through again. She allots 40 minutes for a surgery and 20 minutes for a routine office visit. Bryn cannot do more than 16 surgeries in a day. This sentence is important. Bryn cannot do more than 6 surgeries in a day. She can't do 7 surgeries. It's not in her schedule. She can't do 8 or 9 or 10. It's 6 or less than. So that means the surgeries, which is our x variable, x has to be less than or equal to 6. Does that make sense, everybody? She can't do more than 6, so x has to be less than 6, less than or equal to. So there's another one. Now our final system of inequalities that we're going to write here, the last linear equation, is the office has 7 hours available for appointments. Okay, so it can't go 7.5 hours, can't go 8 hours. It has to be less than 7 hours, or less than 420 minutes. So this 420 minutes, we know that she can't do more than 420 minutes. So with her surgeries and her office visits, it can't be more, it has to be less than 420. So now we got to ask ourselves the question, how many minutes does a surgery or does an office visit take, and how many minutes does a surgery take? Well, a surgery is 40 minutes. So 40 times the amount of surgeries plus 20 multiplied by the number of surgeries has to be less than 420. This equation right here is hard to pick out. Okay, hopefully that makes sense to you though. X is the number of surgeries, so if she does 4 surgeries, there's 160 minutes. Okay, and she can't do any more than 420. So there's this, the surgeries plus the office visits have to be less than 420. So there is all of the system of inequalities. This part right here with the $55 and the $125, that's going to be our function to be maximized or minimized. So that's going to go down here. So now that we have all 4 of these, we're going to graph them. X has to be greater than 0 and Y has to be greater than 0. If you think about this, class, don't write this down for a second. Here's X is greater than or equal to 0, shading everything this way. Here is Y is greater than or equal to 0, shade everything up. So hopefully you guys can see that we're going to be working in the first quadrant here. Our shading, that common part right there, is going to be in the first quadrant. It's not going to be in the second, third, or fourth quadrant. So with that being said, let's not make a mess of our graph here. We're just going to say, I know that it has to be greater than 0 on the Y and greater than 0 on the X. So all of our work is going to be done in the first quadrant. Don't even worry about the other ones. So we've already graphed this one. We've already graphed this one. Now we're going to graph this one. X has to be less than or equal to 6. So we're going to go to 6. An X equals line is a vertical line. So here is X equals 6. Okay, and it has to be less than or equal to it. So that means the shading is going to be left. So my shading is going to be right in here. Once again, class, I'm not going to draw that shading yet. Hopefully you didn't yet. I just don't want to make a mess. Let's just remember that it's to the left of the blue line. So now the last one is graphing 40x plus 20y is less than or equal to 420. Let's put this into slope-intercept form, shall we? So now I'm going to subtract 20y, or sorry, I'm going to subtract 40x. So 20y is less than or equal to a negative 40x plus 420. Divide both sides by 20, and we have it made. So y is less than or equal to a negative 2x plus 420 divided by 2 is 21. So now we're going to graph this one. Has a y-intercept of 21. So 21 is approximately right here. And then it's a slope of down 2 over 1. So I know that these go in increments of 4, but if we go still down 2 squares, it's kind of like going down 8, and then right 1, which is kind of like going right 4. Isn't 2 over 1 the same thing as 8 over 4? It's the same fraction. So we can still continue to go down 2 over 1. So down 2 over 1. Down 2 over 1, down 2 over 1, so on and so forth. So let's draw a solid line that connects these dots. And there's that one. So now this is a less than or equal to. So less than or equal to means that we shade everything below the line. So there's my black line up there, and I'm going to shade everything below the line. So where is my bounded region? It's everything in the first quadrant. It's left of the blue and below the black. So as you can see, our bounded region is right there. There's where all of my shading comes together. It's that trapezoidal figure right there. Okay? So with this, our function to be maximized or minimized is always going to lie at the vertices. That's just the way it works out, where the vertices will always have a function to be maximized or minimized, or is going to have that maximum or minimum value. So when we write this function to be maximized or minimized, we want to find a combination of office visits and surgeries that maximizes the income. So here's what I know, class. I know that she gets $125 for every surgery she does. So that must mean 125 times X. Because like I said, if she does one surgery, it's 1 times 125. If she does 2 surgeries, it's 2 times 125. If she does 3 surgeries, it's 3 times 125. That's how much money she makes for surgeries. In the same way, she gets paid $55 for an office visit, which is our Y variable. So 55 multiplied by Y. This is my function to be maximized or minimized. 125x plus 55 multiplied by Y. So now we got to ask ourselves the question, what are our vertices of our bounded region? Right? They are going to be right here. That's the coordinate 0, 0. Another vertice of our bounded region is way up here. It's at left and right 0 and up 21. So she could do 0 surgeries and 21 office visits. Another one is right there. That blue line is at 6. So it is right 6 and up and down 0. And our last one is right here. This one might be kind of tricky to find the Y value. We know what the X value is. That blue line is 6. So we know X is 6. And we could kind of make a good guess about where Y is. But to be sure, let's just use our knowledge of math. We know that this right here is that black line. And we know that that black line has 6 on it. We want to find what Y coordinate it is right there. So if we know that Y equals a negative 2x plus 21, and we know what our X coordinate is, we want to find our Y coordinate. So what's Y when a negative 2 is multiplied by 6 plus 21? Does that make sense, everybody? Here's our line. And we want to find out what point this is. We know the X coordinate is 6, so that's why we put that in right here. And we want to solve for the Y coordinate. So now we have a negative 12 plus 21. So that means Y equals a positive 9. So this point right here is 6, 9. Okay? 6, 9. And there are all 4 of our vertices. So with that, we're going to find the one that pays the most amount of money. So we're going to say 125 times 0 plus 55 times 0. Well, that's just going to give you $0. If Bryn doesn't do any surgeries and she doesn't do any office visits, she makes $0. That just makes sense, right? If she does 125 times 0 plus 55 times 21, if Bryn's like, you know what, I don't want to do any surgeries, all I'm going to do is office visits. If she only does office visits, she could do 21 of them, she would make $1,155. Not bad for a day's work. Now she says, you know what, that's just too many office visits. Let's see what happens if I were to do 6 surgeries and no office visits. So if she does 6 surgeries, 6 multiplied by 125 plus 55 times 0. If she only did surgeries, she would make $750. Not quite as much. And the last one, if she did a combination where she's like, I'm going to do 6 surgeries, and I'm going to do 9 office visits. If that is the case, she would make a total of $1,245. So if we ask ourselves the question, select the greatest or least to answer the question. Well, to answer the question, we want to find out how she can make the most amount of money. That's what it asks up top. So we're going to write this, and everyone write it down with me. Bryn should do 6 surgeries and 9 office visits. Oopsie. Office visits to maximize her profit of $1,245. I really want you to answer your question that detailed, because that's going to tell me that you know exactly what is happening in this problem. Tell me the name of the person, what that person is supposed to do as far as this x and y coordinate is concerned with relationship to the variables, x being surgeries, y being office visits, to maximize her profit at $1,245. Whew, a lot of work, class. It is time consuming, but it is possible. I want you guys to pause the video, and I want you guys to try problem number 2, and then check your work with mine. Okay, Ethan owns a landscape company. He has a crew who mows lawns and prunes shrubbery. The company schedules 1 hour for mowing and 3 hours for pruning. Each crew is scheduled for no more than 2 pruning jobs per day. Each crew's schedule is set up for a maximum of 9 hours per day. On the average, the charge for mowing lawns is $40, and the charge for pruning shrubbery is $120. Find a combination of mowing and pruning jobs that will maximize the income of Ethan's company that he receives per day for one of its crews. Well, define the variables. Once again, if you look at the graph, it says that the x variables is mowing. So this one's mowing, and this one is pruning. So the x mowing, y pruning. And then hopefully you did this right away. Hopefully you said, well, system of inequalities, we know that x has to be greater than or equal to 0, and y has to be greater than or equal to 0. So once again, all we're worried about is the first quadrant. We're not even going to focus on the other quadrants. And then another one here is, hopefully you caught this part. It says each crew is scheduled for no more than 2 pruning jobs per day. So they can't do 3 pruning jobs. So our y variable, which is pruning, y has to be less than or equal to 2. They can do 0, they can do 1, they can do 2, but they can't do 3 or more. 2 is the maximum. So now they are scheduled to work 9 hours per day. So if they're going to work 9 hours per day, I know that mowing takes 1 hour, so the x variable is multiplied by 1. It's 1x. And the y variable, it takes 3 hours to prune. So 3 times y. That has to be less than or equal to 9. They can't do more than 9. So those are our 4 equations. Hopefully you got that on your own. Let's graph it. X and y greater than 0. I don't even have to graph that. I just know that it's going to be in the first quadrant. Y is less than 2. So here is 2. Oofta, my smartboard is a little bit off here. There's 2, and it's everything less than that, so it's everything below the green line. I'm not going to shade that because I don't want to make a mess. And then my other equation, this one I'm going to graph by putting into y equals mx plus b. So let's subtract that 1x. So now 3y is less than or equal to x plus 9. Divide both sides by 3. And I get y is less than or equal to 1/3 x plus 3. So my y-intercept is 3. Oopsie, this should be a negative x, shouldn't it? I subtracted that x, so it's a negative 1/3 x plus 3. So I have a y-intercept of 3, and my slope is down 1, right 3. 1, 2, 3. Down 1, right 1, 2, 3. Down 1, right 1, 2, 3. So there is my line for that equation. And now it's going to be everything that's less than or equal to it, so that means we're going to shade everything below the line. So once again, I get a trapezoidal figure where my shading is in the first quadrant, it's below this green line, and it's below the blue line. So there is my solution. That's where all 4 of my equations have that common shading, right in that black trapezoid. Okay? Write a function to be maximized or minimized. He wants to make the most amount of money, $40 for mowing lawns and $120 for pruning shrubbery. So X is mowing. So it was 40 multiplied by X and 120 multiplied by Y. That's going to go right here. 40X plus 120Y. Our 4 points are once again 0, 0. Hopefully that's clear that it's not going to be that answer to you that's the most amount of money. It's going to be this point right there, which is 0, 2. It is going to be this point right here, which is on the x-axis, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. So 9, up and down 0. Or we have this one that is right there, which is right 1, 2, 3, and up 2. Or right 3, up 2. All right, hopefully you got that part. Once you did that, you simply do the math. 40 times 0 plus 120 times 0 equals 0. Easy enough. 40 times 0 plus 120 times 2 is $240. So you'd make $240. Did I do that right? Yes. And then we have our 9, 0. So we're going to have 40 times 9 mowing jobs plus 120 times 0 pruning jobs, and he would make $360. And our last one, he could do 3 mowing jobs at $40 plus 2 pruning jobs at $120. So we would have 120 plus 240, which is also 360. So, select the least or greatest to answer the question. Once again, we want to find the greatest or the maximum because we want to find how Ethan can make the most amount of money. And he could do one of 2 things because they're both $360. So to answer the question, Ethan can do 9 mowing jobs and 0 pruning jobs, or he can do 3 mowing and 2 pruning jobs. Both maximize his profit at $360. There's the answer for that one. So this is kind of some profitable information for Ethan to know. He could get $360 for doing either of those 2 things. So let's say maybe mowing is easier. He wants to maximize his profit at $360. He doesn't feel like pruning because mowing is easier. So bam, he's going to do 9 mowing jobs and he's not going to even worry about pruning. Maybe there's one day where he's out of gas where he can't do any of his mowing, but he has some clippers so he can at least do his pruning jobs. Well, now he can at least do something there, and if he did that, he would make $240. It's not too much less. So those kind of things are very profitable for Ethan to know. So very good information. I hope that makes sense to you. If anything didn't make sense, be sure to ask me in class tomorrow.